Welcome to my channel Data Science for Everyone. In this video, I will predict the optimum number of clusters using unsupervised machine learning and represent them visually. First of all, we have to import the necessary libraries, that is pandas. Pandas is used for mathematical calculations and NumPy as NP is used for the analysis and matplotlib is used as visualization. Here I am using sklearn.dataset as dataset uh, to load my iris dataset. You can also use a CSV file and load that file, but I'm using this sklearn library for loading of the dataset because it is predefined in that library. The iris datasets are predefined in sklearn dataset. So this command will load the iris dataset. Now I'm just generating the data frame of my dataset and then just printing my dataset. Here it shows the number of rows. It has 150 rows and 4 columns. You can also check if your data is correct or not with the help of .head method that will print out your first 5 entries, and you can also check the last 5 entries also with the help of .till method. And is null method will identify any null value in your data. And info method will show the information of your columns. Here it shows that the columns are in centimeters and their data type is float. You can also use .describe method that will explain you the stats of your data. The count, mean, standard deviation, minimum value of your data, 25% and 50%, 75% and maximum value. And shape will explain you the shape of your data, that it has how many rows and how many columns. In our case, it has 150 rows and 4 columns. Dot size will tell you the size of your data, that is in our case it's 600. Now I will find out the optimum number of clusters for k-means classification. I'm using the algo method. Here I am using sklearn.cluster and I am importing the k-mean from that library, and here is the empty array that is within the cluster's sum of squares. We can also call it as the inertia, and I'm using the simple for loop, and this range will show the number of clusters. It shows that we have 10 clusters, and clusters will tell you the number of clusters in it is used as per the initialization, and we will use the maximum iteration, that is 300, and its random state is 0, and yes, it is 10, that because we have 10 clusters. Now we will append in our array k-means dot inertia, and then we will plot our results. Here it shows in y-axis we have the within cluster sum of squares, and in x-axis we have number of clusters. We can see that the value is decreasing very rapidly, but when it reaches to this level, it remains the constant. So we have this is the optimum value, and it is 3. So we'll just replace the n clusters with 3 and we'll load our data. Now for the visualization, I'm using the dot scatter method, and here I'm using the matplotlib library. Here S is the size of the marker, C is the color of the cluster, and label is the name of the iris data cluster. We can also visualize it. Iris setosa is shown with the pink color, iris versicolor is shown with orange, and iris virginica is shown with yellow. And iris centroid is shown with the purple color that is clearly seen. For the orange it is this, for pink it is this, and for yellow it is this. So yes, this concludes our k-means clustering, and this shows the visualization. Thanks for watching.